Hello, welcome to our next PowerPoint, the foundations for the cost structure of a business. In this PowerPoint, we'll review three basic items, the first of which is how resource inputs influence the quantity of outputs that we get in any sort of production operation, and that applies to any sort of setting, whether it be retail or a restaurant or a manufacturing firm, for instance. From there, we'll move on to see how understanding those relationships drive the dollar costs that we see, and that those dollar costs, some are fairly fixed and do not vary as we change our output, and those that do vary as we change our output. Lastly, we want to look at illustrating how those costs behave on a per unit basis, because those will give us some insights on ultimately how we can maximize our output for the needs of a business. So let's follow along. The relationship between resource inputs and production outputs. Our production function shows us the relationships between resource inputs and the quantity of outputs that we receive. Intuitively, we do understand that as we add additional inputs, that the output that we receive also increases. However, also important, the production function does show us that there are limits to this, that at some point, as we add additional inputs, that the quantity of output that we receive may actually decline. While our production function shows us the relationship between our inputs and our total output, sometimes it's a little bit difficult to see how those two are related. Our marginal product curve, or our marginal output curve that we see here, does a little bit better job of that, because what it's showing us is the relationship between adding one more resource input and what the change in the output is. So as we look at this, if we look at the fourth unit of our inputs, that fourth unit gets us 12 more units of an output. If we add one more unit, the fifth one, that ends up giving us only 11 more units of an output. So some of the things that we can see here with the marginal product curve is, first, that as we add inputs, generally our efficiency does improve. We get additional units of an output. But there does come a point where, in effect, we reach our maximum efficiency. Any inputs we add after that, the additional output that we get starts to decline. And ultimately, there will be a point where if we add more inputs, that the total output we get actually declines. On this particular marginal product curve, that happens when we pass the 8th unit of an input. Because if we use 9, it actually takes 2 units of an output away from what our total is. So this suggests that in this particular circumstance, we would never want to use more than 8 units of an input. This means, of course, that our marginal product curve and our production function are actually related. For instance, if we look at that point where marginal product has reached its maximum, that is also the point where it appears that the production function begins to slope downward. For your mathematicians, that's the point where we would describe the slope as getting smaller. Another point to notice is that point where marginal product becomes negative. At that point, you will notice that that coincides with the maximum level of output achieved on the production function. The relationship between fixed, variable, and total cost. Because the relationship between our resource inputs and our total production output changes as we add those inputs, it also means that our costs are also influenced by this relationship. What we're going to look at here, though, is that there are some costs that do not vary with output, and there are also some that will. So we can examine a relationship between costs in terms of fixed and variable costs. The first of these costs are fixed costs. These are costs that do not vary with the level of output. So what that means is whether I make nothing, I make 1 unit, or I make as many units as possible, these particular costs do not change. Examples of these costs would be, for instance, the rent on a retail store, where if I sell nothing, I still have to pay the rent. So even though output is 0, I have a particular cost, say $500 in this example. However, I could sell only 1 unit, but the cost of my rent is still only $500. I could sell 1,000,000 units, and my rent cost is still $500. Therefore, this is a fixed cost, and that cost does not vary as I change my level of output. Our second type of costs are our total variable costs. These are costs that do vary with the level of output. So this means that if I produce nothing, 0, that our total variable cost will also be 0. As I increase the level of output, my total variable costs also increase. However, we can also see that as our total variable costs increase, it does not increase in a, let's say, a linear fashion. But there is a point where as we continue to add outputs, it appears that our total variable cost rises fairly slowly. And then we reach a point where as we continue to add outputs, our total variable cost really starts to climb. The reason why this total variable cost curve appears to, if you will, snake around like this is a result of our marginal output curve. As our efficiencies increase, our total variable cost, if you will, does not rise quite as fast. But as our efficiencies decrease, what that does is cause our total variable cost to increase at an increasing or faster rate. So, our total cost of an operation at any particular level of output is the sum of our fixed cost plus our variable cost. You can see in the table that as our output increases, our total cost also increases. On the graph, what you can see is that if you add at any level of output the fixed cost and the variable cost, that the two of them vertically add up to what the total cost curve is. So what we do see is a relationship between the third. Our total cost will tend to not be linear in fashion, again, because our marginal output influences the shape of this particular cost curve. Short-run cost curves. While our total cost curves helps us see the difference between fixed costs and variable costs, ultimately what it tells us, of course, is that if we produce more, it costs us more. What it's not necessarily very good at is showing us how those costs behave over changing levels of output. For that, we're going to look at the short-run cost curves, which are going to include our average fixed cost, our average variable cost, our average total cost, and an additional function that we can look at that is marginal cost. Average fixed cost is total fixed cost divided by the quantity of output produced. In examining our average fixed cost curve, what we notice is because it's fixed, the average will continually decline. As output increases, our average fixed cost will always decline. Our average fixed cost will never increase as our output increases. Our average variable cost is our total variable cost divided by the quantity of output produced. If you notice, as we increase our output, our average variable cost will decline. And at some point, that average variable cost will start to increase again as we increase our output. Again, ultimately, this is being driven by our marginal product or our marginal output curve. Our average total cost is found by dividing total cost by the quantity of output produced. But because of the way averages work, if you notice, we can also find our average total cost by simply adding our average fixed cost to our average variable cost. If you look in this example at 4 units of output, we can add the graph vertically. So our average fixed cost of 125 plus our average variable cost of 200 gives us an average total cost of 325. When we're looking at our average cost curves, our graph also reveals something that because we vertically add them, the value of our average fixed cost actually shows up as the difference between our average total cost curve and our average variable cost curve. So in this illustration, we can look at this gap between 0 and the average fixed cost curve and compare it to the gap between our average total cost curve and our average variable cost curve. And what do we find? That gap is exactly the same. So for this reason, even though our short-run average cost curves are made up of our average fixed cost curve, our average variable cost curve, and our average total cost curve, there really isn't a need to display the average fixed cost curve since we can tell what it is by looking at the difference between average variable cost and average total cost. Our last short-run cost curve is the marginal cost curve. This curve shows us the additional cost for producing one more unit of an output. Placing the marginal cost curve on top of the average total cost and average variable cost curves also helps us illustrate the marginal average rule. What we will find is that the marginal cost curve always crosses the average variable cost curve at average variable cost curve's minimum point. It also means that it will cross the average total cost curve at average total cost curve's minimum point.